Welcome to Math with Mrs. Seeley. Let's get started with 2023 free response question number 2. Recall that question number 2, a calculator is allowed and actually necessary. Stephen swims back and forth along a straight path in a 50-meter long pool for 90 seconds. His velocity is modeled by this equation right here, where t is measured in seconds and v of t is measured in meters per second. All right, A part says to find the times in the interval where Stephen changes directions and give a reason for your answer. You know or recall that you'll change directions when the velocity changes signs. So when your velocity changes signs, that means from negative to positive or positive to negative, or probably more easily when the velocity is equal to 0. So we need to go to the calculator and type that in and find out when the velocity is equal to 0. So you know that you're going to go to y1, your equation, and type it in. So you're going to type in your velocity function. You're going to need to fix your window. So we need to be able to see that x max from 0 to 90. So go in and kind of fix that. And then you go to second, calculate. Some people think of that as blue trace. So hit your blue trace button. But don't hit trace. Go to second, calculate. Option 2. That's the 0. It tells you where you're equal to 0. And then after that, it's just an enter, enter, enter. And when you do, you're going to get t is equal to 56 seconds. So we would say that Stephen changes directions at t equals 56 seconds because his velocity changes signs, or equals 0 if you want to say it that way. All right, if you knew to look at the fact that the velocity was going to change signs or equal 0, you knew that theory, give yourself a point. And then give yourself a point if you were able to say that he changes direction at 56 seconds because his velocity changed signs or was equal to 0. All right, B part. Find Stephen's acceleration at time t equals 60 seconds. Show the setup for your calculations and indicate units of measure. Is he speeding up or slowing down? And we'll give a reason for our answer. Recall that you have position. Take that derivative and you're going to get velocity. And if you take that derivative, you're going to get acceleration. So if I'm asked to find the acceleration at 60, I know that's really just taking the velocity at 60. Go to your calculator, and you're probably very familiar with Math 8. That allows you to do the derivative, and you know that it looks just like that. And you're going to fill in your function, and then it has this right here. So as you fill this in, you're going to put your x there. You're going to put in your v of t, type it in very well, correctly, and then you're going to say x equals 60 right there. Very easy. So when you put that in, you're going to get negative 0.036, and so that is your acceleration. And make sure you say that that is in meters per second squared, because it definitely said to indicate units of measure. If you got your units right, meters per second squared, give yourself an answer. If you got this value right, give yourself another answer. Okay, now the next thing it says, is he speeding up or slowing down? Okay, let's think about this. All right, we know that acceleration is negative at t equals 60. We just found that negative 0.036, right? Let's look at velocity. The velocity at t equals 60 is also negative. In fact, if you do that, you're going to get negative 0.156. I found that by taking the time of 60 and going and plugging it in for t. Just plug that back into the original, the velocity function at t. All right, so I know that the acceleration is negative. I know that the velocity is negative. Since they have the same signs, Stephen is speeding up. Stephen is speeding up at t equals 60 because both acceleration and velocity are negative. They have the same sign. Think of it this way. If you're being pushed in the direction you're already going, you're going to be speeding up. You're pushed in the direction you're already going. If your signs were opposite, like one was negative and one was positive, then he would be slowing down. If you were able to say that he's speeding up and give the reason why, give yourself another point. All right, C part says find the distance from his position at time it's 20 seconds and his position at time t equals 80 seconds. Show the setup. Again, let's recall. We said that if I'm going this direction, if I take the derivative of velocity, I get acceleration. But if I go in this direction and I integrate velocity, I'll get position. So I need to integrate my velocity function to get position or distance. So I'll set up my integral from 20 to 80, and I'm going to integrate the velocity function, v of t dt. If you knew to integrate velocity to get distance and set that up, give yourself a point. If then you're able to go to the calculator and do the Math 9 calculation and get 23.384 meters, give yourself another point. If you're not sure about that, remember that you go to Math 9. It'll give you boxes to put your limits of integration. It's going to give you a box to put in your function, and right there. So again, you would just go put in the 20 here, the 80 here, type in that v of t very carefully, and put your x right there. Okay, the last one says find the total distance. All right, total distance means absolute value. You got to use absolute value if you want the total distance. So again, we're going to integrate velocity to get the distance. The only difference is from C part and D part is, first of all, it asks from 0 to 90, and then I have to use absolute value of that to get my answer. If you knew to do absolute value of that velocity function, give yourself a point. Then if you put that in the calculator correctly and you got 62.164 meters, give yourself the last point on this question. Just when you go to plug this in under Math 9, make sure when you fill in your boxes here from 0 to 90 that you put in this absolute value before you put in your function. If you forgot how to do that, you go to Math, go to NUM number, and it's option 1 ABS. I hope you found this helpful in preparing for your AP Calculus exam. If you did, please like, comment, and share, and subscribe to the channel. Be sure to check out other AP Calculus questions and other calculus tutorial videos on the channel. See you next time.